In this item, we are asked to find a couple of unknown member forces. We have one member that has 82 kips of force, the other has 50 kips of force. We recognize that we have all forces pass through common point. It's called the working point, and that tells us that we have a concurrent force system. And in 2D, that means we have two independent equations of equilibrium, sum of forces in the x, sum of forces in the y, to work with to find our two unknowns, the forces in the member B, the forces in the member D. Now note that if we sum forces in the x, we'll get both the two unknowns in it, and that's not maybe as helpful or as easy to work with. But if we go sum of forces in the y, we only have one unknown. Let's try that as step number one. Equilibrium in the y direction, and we would have sum of forces in the y. Let's take downwards positive. We get 50 going down, minus, nope, plus, because TD is shown as going downwards. And so 40 degrees is with respect to the horizontal. We want the vertical component that's opposite of the 40, so that's sine of 40 degrees. Set it equal to 0. Therefore, TD equals a negative, well, let's find out, 50 divided by 40 sine 77.79. Okay, we're not going to do anything here with direction just yet. We'll interpret directions later. Let's now look at equilibrium in the y direction. Let's sum forces positive going to the right, so we'll have minus 82 kips. The 50 doesn't get into it. We've got, as shown here, a positive negative 77.79 times cosine of 40 degrees plus t sub b. Set that equal to 0, and so we've got two negatives that go to the other side. They become a positive, so we'll have that times 40 cosine plus 82, and we get 141.6 kips. So now we have a positive for there, and so our answer from this stage in a statics class, then what you might say is your answer. It's a little different than what it will be after we get into the next block where we talk about real truss analysis, but our T sub B would equal 141.6 kips. Now that actually is a member force. It does not have a direction. It has a flavor, tension, or compression. But as shown here in this case, you could say that that has an arrow such that there. What the real answer ought to be later on, and at the end of the course, that would be your real answer that you'd have. For T sub D, we have then 77.8 kips acting on the joint upwards to the left. Again, that's really nonsensical for a truss member force. You don't know that yet. The real answer ought to be 77.8 kips in compression, because the opposite sign turns us around. The rest of the member is squeezing on that, and that means the joint is squeezing on the member. But for the test, this is sufficient as an answer.